Welcome to Summarize Science, where we break down complex research into simple terms. Today, we're looking at a huge challenge for the AI assistants that are becoming part of our daily lives. These AI agents can use tools to book appointments, manage files, or access data, but how do we ensure they only do exactly what we ask them to do? This paper tackles that very problem. The researchers point out that current systems often grant overly broad permissions. As shown in this diagram, a user might make a simple request, but a faulty or malicious agent could ask for access to extra, unnecessary tools. In today's typical setup, if the agent technically has permission, the system grants access, creating a major security risk. To fix this, the researchers propose a new model for delegated authorization. Instead of just checking a list of allowed permissions, their system semantically inspects the user's original request. It uses a trusted large language model to understand the meaning and intent of the task. This auth server then compares the user's intent to the specific tool the agent wants to use. Essentially, it asks, does the agent really need this tool to complete the job it was given? If the tool's function doesn't match the task's goal, access is denied, as you can see in Flow B on this chart. This provides a just-in-time, least privileged security check for every action the agent takes. A major hurdle for the researchers was the lack of data to test such a system. So, they created ASTRA, a brand new dataset and pipeline designed specifically for benchmarking this kind of semantic matching between tasks and tools. This was a critical step, as it allowed them to simulate both appropriate and inappropriate requests to see how well their system performed. So, how well did it work? The results show that the new model, especially the LLM-based reasoner, is highly effective, particularly for tasks requiring a single tool. However, the challenge grows as tasks become more complex and require multiple tools. The model becomes more likely to mistakenly reject a valid tool request. This chart perfectly illustrates the core challenge, balancing security and usability. Overscoping means granting too much access, which is a security risk. Underscoping means denying necessary access, which can cause the application to fail. The goal is to be the ideal matcher right at the corner, and this research moves us much closer to that. So, let's recap the important points. Standard authorization for AI agents is risky because it doesn't understand user intent. This paper introduces a new system that semantically matches an agent's request to the user's original task, granting permissions that are minimal and temporary. This is a huge step forward for what's called task-based access control, or TBAC. In the future, this could enable us to confidently delegate complex work to AI agents, knowing they have intelligent guardrails to keep them operating safely and within their intended scope.